Back from the break. Here we go. Mostly this is a reminder on how to do things. Just one new thing. That's problem number 4. And it's only minorly new. So we got calcium and oxide, and we want to do Lewis dot to figure out what kind of formula we would have. So I would have to go over here and take a look at Lewis dot. Oh, my pen's not showing itself right now. There you go. Lewis dot. So I'd look at calcium, which is right here. Boop. Second column down, so it wants to lose 2 electrons, oxygen. Second one over from the noble gases, so it wants to gain 2. So we write that calcium has 2 dots on it. Oxygen has 1, 2, 3, 4, 5, 6. So to make these things work, 1 goes in there, 1 goes in there. I should probably write it as CaO and then draw the 2 dots in between, 2 dots, 2 dots, 2 dots, 2 dots, showing that oxygen is completely happy. But you technically don't have to. I just want you to be able to figure out the formula because that's all Lewis dot is for, at least in this case. And so I have 1 Ca makes 1 oxygen happy, and I am done. That is my formula. By the way, I'm going to start talking about what we're going to call this. This is calcium oxide. All right. Okay, so next one here, I've got, you should be able to do number 2 by yourself. It's almost exactly the same thing. Let's do number 3. Number 3 is carbon. Remember, carbon's in a weird spot. It can lose 1, 2, 3, 4, or it can gain 1, 2, 3, 4. So it doesn't know what it wants to do, but it acts like it's got 4 in its outer shell, which is what it has in its outer shell. So that's a good reason for it to act like that. And then I have hydrogen. Hydrogen's over here. Hydrogen wants to lose 1. It's got to get down to 0 because that's a perfect shell because it has none. So that would be hydrogen. Put hydrogen right here. It has 1. So then I put down my carbon. Boop, boop, boop. I'm going to put a hydrogen right here and pair it up. But that only makes 1 of the hydrogens happy. Second hydrogen's happy. Third hydrogen's happy. Fourth hydrogen's happy. So now carbon has 8 dots around it. All the hydrogens have lost all their dots, so everybody's happy. So it's CH4. All right. So this should be review. Again, it's a little rusty, understand. We would call this carbon hydride. Now, to be fair, nobody would call it this. This is also called methane because it was discovered before we knew how to do formulas. All right. So the next one down here on the list, and by the way, if you call it carbon hydride, that's fine. Chemists know what that is. Okay, next one is iron. So iron is out here, and suddenly we have a crisis of conscience. That's iron. And then we have oxygen, and we know oxygen's right here. And oxygen wants 2 electrons. Now, what does iron want to do? Iron wants to either lose 1, 2, 3, 4, 5, 6, 7, 8 to go from 26 electrons to 18, or it needs to gain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get from 26 to 36 to gain 10 electrons. It needs to lose 8 or gain 10. Now, here's the problem. Iron still has positive in the middle, right? If you think about it, iron has a big positive core. In fact, it's got 26 electrons 26 protons in there, right? So it's got electrons, got another shell of electrons, it's got another shell of electrons, and then we got this shell with 8 in it. And it needs to lose all 8 or gain 10. Well, sure, you can lose 1, 2, 3, 4, 5 or so, but when you start talking about 8, that's too many. And as you start to pull electrons in to try to get to 10, this thing's going to become more negative, and negative and negative. It's got to attract more electrons, which electrons don't like negative, right? And the same charges repel each other. So iron really can't do either. So iron just kind of hanging out going, okay, whatever. You guys tell me what to do, and I will do it. In fact, if we were sitting in class right now, I'd now burn a steel wool. Steel wool. I don't have it in the house. But steel wool, maybe I'll show it to you next time. Steel wool, when you burn it, turns into two different colors. It turns into red and black. Well, red is the electrons that lost 2 electrons. The black is the one that lost 3. And so it does 2 different things. So how do we keep track as chemists? Because we're lazy and don't really want to, okay, show me the thing that you're talking about. So we have to have words for them. And so here's the little game chemists play. This is a game you're going to like. You're like, I don't like games. Roman numerals, But look, that's a Roman numeral 2, right? So what are they telling me? Iron 2 and oxygen. Why 2? What is it telling me? Oh, 2 means how many electrons it's going to lose. So I put 2 in its outer shell. Now, who's it going to lose it to? Oxygen. And that's why it's going to choose to lose 2, because oxygen wants how many? 2. So when these two run into each other, that Fe has 2 it wants to lose. Oxygen, 1, 2, 3, 4, 5, 6. 8 happy. Iron's lost all its electrons. Everybody's happy. The formula is FeO. Okay. So with metals, I have to tell, that's what these all are, right? These are metals. Oddly enough, the reason why they're shiny is because they lose the amount of electrons you want them to lose. That's oddly enough. And so all of these are metals. Okay, well, don't believe me? Let's see some metals you might know. Here we got copper, silver, gold. Okay. That's another one you might recognize. Platinum is right here. Nickel, as in the coin, nickel, right there. Okay. I don't think you'd recognize most of the other ones. Chromium you might have in your house. You might have something that's chromium. That's also a beautiful metal. But all these are metals. Okay, so therefore, mercury, the liquid metal, right? Right here. Okay. So all of these are metals, all of these are shiny, but more importantly for our discussion, they don't choose how many electrons they want to lose or gain because it's too many. They're too far away from the finish line. So you know what they do? They say, you know what? You tell me what you want to do and I'll do it. Okay? So it gets our cute little rules start to fall apart a little bit here in the middle. So when we talk about one in the middle, we're going to say iron 2 or iron 3 or iron 4 to let you know how many electrons each one has lost because there's no way to know otherwise. Unless I burn it in front of you and say, hey, look, it's bright red or whatever. Okay? All right. That should do it for today. Finish up the rest of this worksheet. Submit as always.